Okay, this is the Math Connections video for the week of January 4th. So this is our remote learning week. As I mentioned yesterday when we met on the Google Hangout video, you guys were going to have some notes to take and then some homework problems to do after, and then turning both of those things in on Google Classroom when you're done. So notes need to be completed, problems and answers, and then homework questions need to be completed separately. Questions and answers. So this is your reminder to turn your sound up so that you can hear what I'm saying in the video. I will post these both today. The notes will be a video and the homework questions will just be pictures. So again, make sure you're copying down not just what the work and the answers are, but I need you to have the original problems written down both in your notes and in your homeworks, because if you just write down answers to these notes, they're not going to make sense when you use them to go do your homework later. So what we're going to do is recap the unit of proportions and scale ratios that you guys were doing before Christmas break when I was out for quarantine. So again, instead of having a unit test, we're just going to wrap up the problems that you did, do a little bit of both type of problem here in these notes, and then you have homework questions. So this is instead of doing a proportion and scale ratio unit test, okay? So I'm gonna solve these with you, and make sure you're copying them down on your own paper, numbering them, and of course put your name on it so I can see that it's you when you turn it in. So the first kind of problem that you did before scale problems was you solved proportions. Now proportions means that you have a ratio or a fraction of two numbers. You have a ratio on either side of the equal sign. So if I asked you to solve the proportion, you're solving for the unknown number. Okay, so it could be represented by any letter. It could be X, could be Y, could be A, B, C, anything. But it looks like all of these problems are going to use X. So the trick here, and you're going to use this with your scale ratio problems too, is you want to use cross multiplying. Okay, so some people call this the butterfly multiplying or the butterfly method because you multiply diagonally. Okay, I'm going to move my camera down a little bit so we can get closer to the problems. Okay, with these proportions, when you are cross multiplying, you want to keep your equal sign in the middle. All right, so in number one, I'm multiplying 8 by 7 and 4 times x. So 8 times 7 is 56. Equal sign stays in the middle. Sorry, my phone's gonna keep refocusing. But 4 times x, I can only write that as 4x. Okay, I can't get one number because I don't know what x is. So the last thing to do is to get the letter you're solving for all by itself. And what you need to do is move away the 4. How do you move away the 4? Well, right now it says 4 times x. What's the opposite of times 4? Divide by 4. So you need to do the same thing on both sides of your problem. And if you do 56 divided by 4, you get 14. Okay, so the answer to number 1 is 14. Now if we go to number 2, I'm multiplying 18 times 2, which is 36, and x times 3, which is 3x. So same thing, you always want to get the letter by itself. It doesn't matter what side the letter's on, but you do the opposite of what you see in the problem, and that'll cancel it out on the side that you want it to be gone from. So what's 36 divided by 3? 12. Equal sign stays in the middle. The variable's all by itself on the right. All right, I'm not going to do all of these. Let's just do the first 6. So you should have 6 proportion problems in your notes. And then we're going to do, I think, 2 scale model problems. So not that many problems. I think a total of 8 is all you'll need to have in your notes. But when you are solving a proportion that's set up, always multiply diagonally. Do not multiply straight across. Okay, that's when you're multiplying just fractions. We are solving proportions here. So make sure you have the original problems copied down. 12 times 4, 48. 1 times x, 1x. If we divide by 1, cancels out over here. 48 equals x. Fourth one, 9 times 7, 63. 3 times x, 3x. 63 divided by 3 is 21. Okay, and if you guys need to pause or rewind or see something again, this will be posted as a video link, so you can go whatever pace you want. Fifth one here, we've got 12 times 5, which is 60. Equal sign stays in the middle. X times 6 is 6x. You always want to put the number before the letter. Divide both sides by 6. It will cancel out on the right. 60 divided by 6 is 10. So the solution is 10. Last one here, 2 times 33 is 66. 11 times x is 11x. The opposite of multiplication is division. So you want to divide both sides of the equation by the same number. 66 divided by 11 is 6. So your solution is 6. Okay. Now I'm going to put our scale model problems on here. So remember, when we were doing, even though I was remote from home and Mrs. Oliver was in the classroom with you guys, when you talked about scale model, could be a scale drawing, scale model, scale picture. Scale just means you're given a ratio that represents how much bigger or smaller that object is to the real thing, okay? So anything that has been enlarged in size, we call that an enlargement. So like when you see something that's blown up so that you can see it, like a cell in a science textbook, all right? You can't see that with the naked eye, so it's been enlarged to show you what it looks like. And they probably give you a scale ratio of how much it's been enlarged by. Okay, common examples of scale are usually maps and architectural floor plans, blueprints, buildings, because a map, if you're looking at the map of the United States, you know, we can't look at the whole United States at once, so it has to be shrunk down, and they give you a ratio of, in this case, on a map, 1 inch on the map would represent 5 miles in real life, whatever the map is of. Number 2 that we're talking about is an architect that's designing a building. So he's talking about, he or she, in this problem is the dimensions, so a length times a width of the foundation. So they're making a drawing of an actual building. So the drawing will be shrunk down from the size that the building actually will be. So in the drawing, 2.5 inches, every 2.5 inches represents 3 feet in the actual building. Okay, so this is a drawing. Sometimes you see scale models of buildings that are being built or about to be built, just so you can see what it'll look like in real life. Okay, so scale either shrinks things down for us or blows it up in size so that we can see what it'll look like. Okay, but when you're solving these types of problems, you're setting up a proportion. So the same thing we just did, you're solving for an unknown number using the numbers they give you. So let's do the map problem for scale models. Now on a map, 1 inch equals 5 miles. So that's one of our 2 ratios. So I'm going to keep the 1 and the 5 together. Now, 1 is in a unit of inches, and 5 has a unit of miles. The important thing to remember with scale is that you keep the same units across the top and the same units across the bottom. Equal sign goes in the middle. How many miles are there in 2.5 inches? So if we measured 2.5 inches on this map, how many miles would that be in real life? Well, I need to keep the 2.5, sorry, my phone keeps refocusing there. I need to keep the 2.5 in the numerator because it's in inches. Now, what I don't know is, I'm gonna call it X, I don't know how many miles that is in real life. But now we have a problem just like we had in the last few questions. We have a proportion that we're gonna use cross-multiplying to solve for the unknown number. Okay, so we're gonna do 5 times 2.5, which is 12.5. So 12.5 equals, and this is an easy one, 1 times x. So you can just write x, or you can write 1x, but really, if it's a 1 in front of the letter, you don't ever see it written. Okay, so this one was actually solved for us. X equals 12.5 miles. Okay, so that's our answer to part A. Part B says how many inches there are if, or how many inches are there, maybe is that supposed to say, how many inches are there if two cities are 25 miles apart? So now they give us a unit in miles, but we're talking about the same map. So we've got to use our ratio of 1 inch to 5 miles. Okay, equals sign goes in the middle because we are setting up a proportion. And now I'm going to put the number they give me in the denominator because the number they give me is in miles. What I don't know is the inches between those two, what are they talking about, cities? So again, solving for an unknown, we're going to use the butterfly method. We're going to cross multiply to solve for, I called it the letter x. Now we have 5 times x, which is 5x, and then this is a nice easy 1 times 25. Equal sign stays in the middle. So to solve for this unknown, all you're doing is 25 divided by 5, and our answer is going to be in inches. Probably should write the number first, which is an answer of 5. So on that map, these two cities would be 5 inches apart on the map if they are 25 miles apart in real life. Okay, now let's solve this building problem because we're given dimensions. So if you're talking about dimensions and they give us these two numbers, we've got a length and a width. Okay, so the scale they give us is 2.5. I'm going to write that as 2.5. 2.5 inches on the drawing of the building represents 3 feet in real life. Okay, so this is inches and feet. Now I need to do this problem twice because it's asking what would the actual dimensions in feet be for the building in real life. So I need to find a length and a width in feet. So that's just going to be doing 2 different problems. So let's start with the 40 inches. So I'm going to assume that's the width because it's the smaller of the two. So let's find what 40 inches would be in the real building with a unit of feet. So if I'm using 40 inches, I need to keep that in the numerator. Inches, inches, feet, feet. Let's solve for x. Cross multiply. 3 times 40 is 120. Equal sign stays in the middle, and I'm doing 2.5 times x. So all I have left to do is get rid of that 2.5 by dividing by 2.5 on both sides. Cancels out here. 120 divided by 2.5 is 48. So that would be 48 feet is one of my dimensions. Now we have to do this again, but solve for the dimension that has 50 inches in the drawing. So I'm going to use the same 2.5 over 3. I have to use the same ratio because I'm talking about the same drawing. So now instead of 40 inches, I'm going to use the length they give us, which is 50. And again, I'm solving for x. Cross multiply. So we have 2.5x again equals 3 times 50, which is 150. Now if I divide both sides by 2.5, I'm doing 150 divided by 2.5, which gives me 60. So if it is 50 inches on the drawing, it would be 60 feet on the actual building. So our two answers here, what are the dimensions in feet? 60 feet and 48 feet. So just remember when you're setting up these problems, keep your units next to each other. Same units across the top, same units across the bottom. You're going to be solving for one unknown number. So I'm going to post this video. I will see you guys in a little bit for our Google Meet check-in, and then I will post a picture of your homework problem. So remember, you need to turn in 2 things by Thursday at midnight. Your notes, which are these, and the proportion problems we solved, and then the homework questions. So there'll be 2 places for you guys to turn those in.